Hi everyone, in this video we'll take another set of functions in tf.math module. So let's get started. Let's start with add function. This function has two arguments. First argument is x, which is a tensor that must be one of the following types: be float 16, half, float 32, float 64, and sine integer 8, integer 8, integer 16, integer 32, integer 64, complex 64, complex 128, and string. And the second argument in add function is y, which is a tensor that must have the same type as x. And as you can see here, this function will add each element in tensor x with the corresponding one in tensor y. For example, let's say tensor x has just one element, which is 5, and tensor y has one element as well, which is 3. If we apply this function on these two tensors, the result equal to 8, which is a tensor with one element as well. Now we will use add function from tf.math module. So let's do it. tf.math.add open parenthesis x comma y. As you can see here, this is the result from add function. 1 plus 4, the result equal to 5. 4 plus 3, the result equal to 7. 3 plus 7, the result equal to 10. As we can see here, 3 plus 2, the result equal to 5. 4 plus 3, the result equal to 7. 8 plus 5, the result equal to 13. And the output tensor here has the same type as the input tensor, which is a float 32. And as we said before, we can also apply add function on tensors with data type string, as you can see here. So tf.math.add open parenthesis x comma y, and here is the result. F plus r, the result fr. D plus e, the result is de, as you can see here. S plus w, the result equal to sw. S plus f, the result equal to sf. D plus d, the result equal to dd. G plus s, the result equal to gs. Now let's go to add underscore n function. This function adds all input tensors element-wise. There are two arguments in this function. The first one is inputs argument, which is a list of tf tensor or tf.indexSlices objects. We will talk about tf.indexSlices objects in another video. And the second argument is name, which is a name for the operation. It is optional argument. And this function will return tensor object with the same shape and type as the elements of inputs. It's just like the accumulate n function that we talked about it in the previous video. Now let's say we have three tensors, x, y, and z, all with the same type and shape. Now we will use add underscore n function from math module. So let's do it. tf.math.add underscore n open parenthesis. Now we will type inputs argument, which is a list of input tensors x, y, and z. So now let's see the result. As you can see here, here is the output tensor of add underscore n function and the data type of the output tensor. The first element in output tensor, it is 10, which is 1 plus 4 plus 5. The second element, 9, which is reduced by 4 plus 3 plus 2. And the third element, 16, 3 plus 7 plus 6, etc. Now let's take angle function. This function returns the element-wise argument of a complex or real tensor. And by argument, I mean the angle theta. Let's say we have a tensor with just one element, which is a complex number, a plus bj, where a is the real part and b is the imaginary part. If the input is real, so b equal to 0. Angle function will use inverse tan 2 function to compute the argument or theta. If input is real, so b equal to 0, and that's mean there is no theta or theta equal to 0. Angle function has two arguments. The first one is input, which is a tensor. That must be one of the following types: float, double, complex 64, complex 128. And the second argument, name, which is the name for the operation, it is optional argument. As we know, it's easy to compute theta using inverse tan function of b divided by a. But why we use inverse tan 2 function? It's because inverse tan 2 function more accurate in calculating theta than inverse tan function. If we want to learn more about inverse tan 2 function, check out the link in the description below. An angle function will return a tensor of type float 32 or float 64. Now let's say tensor x has complex numbers, as you can see here, and we want to compute theta for each one of these elements in tensor x. So we will use angle function in math module. Let's do it. tf.math.angle open parenthesis x. Let's run this. And here's the result, as you can see here. Here is theta in radian for the first element in tensor x. And here's theta for the second element in tensor x, etc. And if we make all these elements in tensor x real numbers, let's see what is theta for each one of these elements. And as we said before, theta for real number equal to 0. So for the first element in tensor x, which is real number, theta equal to 0, and the second element, which is real number as well, theta equal to 0, etc. And as we said before, the output of angle function, it is a tensor with data type float 32 or float 64. And if we want to convert this tensor to numpy array, just type this dot numpy. And here's the result. It is numpy array. Now let's take argmax function. This function returns the index with the largest value across axes of a tensor. And by axes I mean the dimensions of a tensor. Let's say we have a tensor with just one dimension. And here's the index of each element in this tensor. As you can see here, the largest value in this dimension is 30. So argmax function will return the index of this value, which is 1. This function has a set of arguments. The first one is input, which is a tensor, and the second one, axis, which is an integer. Its default value is 0. The third argument, output underscore type. It is an optional output data type. You can set this argument to tf.integer32 or tf.integer64. Its default value is tf.integer64. And the last argument, name, which is the name of the operation. The last thing you should know that the argmax function will return a tensor, and the type of this tensor tf.integer32 or tf.integer64. And this depends on output underscore type argument. Now let's say we have tensor x and we want to find the largest number in the first dimension. So let's do it. tf.math argmax function, open parenthesis, x. Now let's run this. You can see here's the result. The first element in the output tensor 1. What does that mean? Let's back to x tensor. X tensor is a two-dimensional array. The first dimension represented by rows, while the second dimension represented by the columns of tensor. So here we will compare between rows to find the largest numbers. The index of the first row is 0, while the index of the second row is 1. As you can see here, 3 greater than 1. So the index of 3 is 1. Now let's compare between 4 and 4. As you can see here, 4 equal to 4. So we will take the first one. The index of the first 4, it is 0 because the index of this row is 0. So we will put 0 here. The last one, 8 greater than 3. So the index of 8 is 1 because it is in the second row and the index of this row is 1. Now let's find the indices of the largest numbers in the second dimension. So let's make this 1. Now let's run this. And here's the results. Now we will compare between columns in tensor x. So 1, 4, 3. The greatest one is 4. And the index of 4 is 1. Because of the index of the first column is 0, while the index of the second column is 1. And the last column, the index of the last column is 2. So here we will put 1, which is the index of 4. Now, let's compare between these elements in each column. And as you can see here, 8 is the greatest element or greatest value. And the index of this value is 2. And we will put 2 here. Now let's take argmin function, which is the opposite of argmax function. It returns the index of the smallest value across axes of a tensor. Let's take the same tensor and apply argmin function. As you can see here, the smallest value in this tensor is 2. The index of 2 is 0, so argmin function will return 0. This function has the same arguments as argmax function. The first one is input, which is a tensor. It must be one of the following types: float 32, float 64, integer 32, asinh integer 8, integer 16, integer 8, complex 64, integer 64, quantize 8, quantize 32, b float 16, asinh integer 16, complex 128, half, asinh integer 32, asinh integer 64. The second argument, axis, which is a tensor that must be one of the following types: integer 32, integer 64. Integer 32 or integer 64 must be in the range minus rank input, comma, rank input. And by rank I mean the number of dimensions of a tensor. The third argument, output underscore type, it controls the data type of the output tensor. You can set it to tf integer 32 or tf.integer 64. Its default value tf.integer 64. The last argument, name, which is a name for the operation. Now let's use argmin function tf.math dot argmin function, open parenthesis x, and let's specify axis argument equal to 0. Here we will compare between these rows in tensor x. So 1 smaller than 3, and the index of 1 is 0, which is the index of this row. And as you can see here, 4 equal to 4, so we will take the first one. And the index of this row is 0, so we will put 0 here. And the last one, 3 and 8. 3 is smaller than 8, so the index of 3 here is 0. And here is the result. Let's change the axis to 1 and see the result. And here is the result. Here we will compare between columns. As you can see here, 1, 4, 3. So we will choose 1, and the index of 1 is 0, which is the index of the first column. Here we have 3, 4, 8, and we will take 3, and the index of 3 is 0, which is the same as the index of the first column. And as we said before, the range of axes must be between minus rank of input and rank of input. And rank of tensor x here is 1. And rank 1 here means that the input tensor is two-dimensional tensor, while rank 0 means that there is just one dimension in tensor x. So we can put minus 1 here, and there is no problem. Now let's take inverse sine function. This function computes the trigonometric inverse sine of x element-wise. Let's say we have a tensor x, and we will apply inverse sine function on this tensor. So the result is y. The elements or values in tensor y must be lie within this range, from minus pi over 2 to pi over 2. This function has one argument, x, which is a tensor that must be one of the following types: b float 16, half, float 32, float 64, integer 8, integer 16, integer 32, integer 64, complex 64, complex 128. And the second argument, name, which is the name for the operation. And this function will return a tensor that has the same shape and type as tensor x. As you can see here, the output of inverse sine function between minus pi over 2 to pi over 2. And the input range must be between minus 1 and 1. Because of the input of inverse sine function is the output of sine function. And the maximum value in sine function is 1, while the minimum value in sine function is minus 1. Now let's say we have a tensor x, and here's the elements of this tensor. First we will apply sine function on tensor x, and the result equal to y. And then we will apply inverse sine function on tensor y, and the result equal to x. And here is the result. And as you can see here, the output tensor same as the tensor x. Now let's take inverse hyperbolic sine function. This function computes inverse hyperbolic sine of x element-wise. Both input and output of this function has a range of minus infinity to infinity. So the range of x from minus infinity to infinity, and the range of y from minus infinity to infinity. This function has two arguments. The first one is x, which is a tensor that must be one of the following types: b float 16, half, float 32, float 64, complex 64, and complex 128. And the second argument, name, which is the name for the operation. And here is inverse hyperbolic sine function. As you can see here, the range of the input from minus infinity to infinity, and the range of the output from minus infinity to infinity. Now let's say we have this tensor, and the elements of this tensor minus infinity, minus 2, minus 0.5, 200, 10,000, infinity. And now we will apply inverse hyperbolic sine. So tf.math dot inverse hyperbolic sine, open parenthesis, x. Let's see the result. Here is the result. And as we said before, the input has a range between minus infinity and infinity, and the output has a range between minus infinity and infinity. So there is no problem when you set any element to minus infinity or infinity. Thanks for watching.